Camps on everyone. Let's start off. So, camps on everyone. So the last thing we did, we started with the graphs and we are playing with XT graphs last time. Okay, let's go ahead with one more. The next thing is the velocity time graph. This is one really important graph. That's because this graph gives you two informations. So if you take a velocity time graph, the slope here, dv by dt is acceleration. So in a slope in a vt graph is acceleration. Suppose if you have a graph like this, the area below the axis is negative area because below the time axis velocity is negative, but time is positive. The area above the positive axis is a positive area. So you cannot treat the whole thing as same area. Area above the axis is positive, area below is negative. So the area under the graph, which is integral v dt, this gives you displacement. Which is x final minus x initial. Now here you have to be careful with the signs. Area above time axis is positive. Area below time axis is negative. If someone asks you to find displacement, that would be positive area minus the negative area. If you want distance, now distance, right? It doesn't matter if you go front or back. The negative area simply indicates you have come backward. So in that case, you take your positive area plus the negative area. You take the magnitudes and you just add them up. So that's the thing about VT graph. Clear with this? In case of an XT graph, we didn't have anything for area, but here the area means something. It does give you displacement. And that is the reason VT graph, right, becomes actually quite useful because it talks about the position, it talks about the acceleration in the same graph. All right. So I'll be sending you one, assignment of graphs only, like, there are like 25, 30 questions of only graphs. I think if you can do that sheet after the class, like that should take care of all the graphs you can do. So we'll do a few questions today and then we'll see that also. Okay, let's clear with the VT graph, everyone. Great. Let's go ahead with a few questions on this and then we'll see the rest of the graphs. This is a VT graph. This is 4 seconds. This is 8 seconds. This is 10. This is 14. This is 16, and this is 20. Hmm. Hmm. Yeah, and this height here is 10 meters per second. This would be minus 5 meter per second. This is your VT graph. First thing, looking at this graph, can you plot AT graph? So they can give you one graph and ask you for another graph. Find distance and displacement. At t is equal to 17 seconds. Yeah, let's get these two. I can ask you total distance, total displacement. So then you'll find the full area. This is a VT graph. The slope gives you acceleration, the area gives you the displacement. If you take the magnitude, then it becomes distance. I think I goofed up the numbers, I guess. Just wait. Yeah, I goofed up the numbers. This has to be 2. Mm, because this triangle no, won't match. The base should be 2. Is it necessary? It was not necessary also, I guess. Then this triangle would get messed up. I shouldn't have given this speed there. Mm, this speed is not given. You can figure it out. That minus 5 is not given. We have to find that value. It's different. Yeah, that's actually minus 20. There I did some changes. So this is 2. And I removed this minus 5 at the bottom here. Now that data was inconsistent. Well, let's see the AT graph. So you just need to find the slopes there. So for this triangle here, the slope tan theta would be 10 by 2. So here the slope is 5. For this line, the slope is 0 because it is flat. But this thing, tan theta, again, this slope is minus 5. So be careful with that. Yeah, this slope is also minus 5 because the opposite angles are same. This slope is 0. And this slope would be, yeah, plus 5 again. So the numbers are good. So this value that didn't give, but you can calculate now. That should be minus 20 because the angles are same. Because this angle and this angle must be same. So if you plot an AT graph, this is how it looks. So initially the slope was 5, so a horizontal line, then it becomes 0. Let me use another color. So this would be plus 5, then you will drop to 0 till 8, then you will drop to minus 5 till 14, and then again you drop to 0, then you'll again bump up and become 5 and 0. So it just looks step functions. Clear with that? There, you just have to find the slopes and you have to plot them. What is the distance and displacement? 17 seconds. So we are talking about somewhere here. So basically this area, one rectangle area, triangle, triangle, rectangle, triangle. So it's just all triangles and rectangles. So this will be half base into height. So that area is 10. This area is 8 minus 2, 6 into 2, 60. This area is 10. This area is minus 10. This area is, yeah, this is not minus 10. This is minus 20, right? That would be half into 480. This is minus 40. Yeah, this is 20 into 2. This is also minus 40. This piece area will be how much? That's a small trapezium. And you can just draw that. So this height was 20. This angle is same. This base would be 3. So tan theta was 5. And that would be 15. So that height is 15. So that area of a trapezium will be half. This base is 1 unit into sum of the parallel sides. That would be 35 by 2 minus. So you just have to create triangles and rectangles and one trapezium and finish it off. All clear with this? So what do you want? Displacement? Do check if I messed up any calculations. That would be plus 10, plus 60, plus 10, minus 40, minus 40, minus 35 by 2. You take with signs. You want distance? You just add up everything. Plus or minus, it won't matter. That you can do the calculations. Clear with that? Can you guys draw an XT graph for this? Draw position time graph for this. No, one thing I'll tell you about graphs. Luckily, right, exam you always have 4 options. It's more easy to eliminate graphs, eliminate options than actually drawing the actual graph. So if they give you options, you should know, okay, यहाँ पे ऐसा होना चाहिए, यहाँ पे ऐसा होना चाहिए. If you have that idea, you will be able to eliminate 3 options. So whenever you see graph questions, never try to draw in an objective exams, right? Always try to figure out, okay, what can go wrong? What is wrong with this? The graph is supposed to look like this at t0, supposed to look like this at this point, and this is not looking like that, so this is gone. That's the fast approach, to get the question done. Drawing is the best, but takes time. So now there are no options, so you have to draw. How will you draw an XT graph? I'll just tell you one thing. If you have an equation like this, y is equal to ax minus bx square. If you remember, this was equation of trajectory. Right, of a projectile motion. And how was this thing looking like? So if you actually put this on a graph, this is passing through the origin, and this is a parabola, like a dome kind of thing. So this is how the graph would look, meaning if you extend this, this is the whole graph. It's an inverted parabola. So if you look at your displacement equation, S is equal to ut minus half gt square, right, or plus half at square, it would look something of that sort. So if you have plus instead of minus, what do you think it'll look like? So if you have y is equal to ax plus bx square, this thing would be a little different. Yeah, you can substitute and check. If you put y is 0, you will get x is 0 and x is negative. X is going negative. The y does become negative. So this graph would look something like this. This should have an idea about how the graphs look approximately. Give it a try. I'll show you how it looks. So you will need this, matlab, how they look. How will an XT graph look like? Whatever you think, try for a minute more, then I'll show you. Just give me a minute. Keep trying. Yeah, let's see how to do this. So let's go step by step for the first part. So when you're drawing an XT graph, let's see the first part. So when you go from initially, let's name them also. Let's call it A, B, C, D, E, and F. Now, when you go from A to B, you can clearly see. We'll assume you're starting from origin. Yeah, that has to be given, but TK. And your initial speed is 0, so your equation will be x is equal to half at square. A is positive here, so that will be like, we already calculated it, so that's 5 by 2t square. So how does this look like? Look at this. On a parabola, if you try to draw this graph, x versus t graph, t is 0, you're 0. As time increases, you increase. So this is how the graph will look for x is equal to t square by 2. So meaning A to B, our graph will actually be like this. So this is a parabola. Then when you go from B to C, your velocity is constant. V is 10 meters per second. Acceleration is 0. So your x coordinate will be simply x is equal to Vt. So it's actually a straight line with a slope there. So the line B to C would be like this. Now when you go from C to D, again there is an deceleration this time. C to D, your velocity is 10. Your acceleration is minus 5. And you know how the equation will look like. So this will be like 10t minus half 5t square. This is an inverted parabola. This is going to look like this. Yeah, but it won't start at the origin here. It has to start from this point here. So from C to D, this will still go up. Understand one thing. As long as your velocity is positive, you're still traveling forward. Making sense? Meaning your displacement will still keep on increasing. Your x coordinate will keep increasing as long as velocity is positive. Your graph will continue to go up, right? And look at this point here. At t is equal to 10 seconds, your velocity becomes 0. In an xt graph, the slope is velocity. So at t is equal to 10 seconds, you're going to take a turn. So at t is equal to 10 seconds, the slope must be 0. That is how you know where it is going to turn. So at that point, it is going to take a turn. After 10 seconds, your velocity became negative. So you are going to turn back. So you're coming down. And this will go on till D. At point D, you can clearly see the velocity is, again, it's not up to scale, but the velocity has become constant, meaning you'll again become a straight line. And after E, that's a curve, and this is a line. Now E to F, again, it will be a positive acceleration, but this time a negative velocity. So E to F, your V is negative, so you'll get x is equal to minus 10t plus half 5 by t square. If you look at this equation and this equation, is the other one, this equation, if you see, there is just a difference of a minus sign. That means whatever you drew here, uska inverted. So your velocity is still negative, so you will continue to go down. And then at 10 seconds, you have to become again flat. At that point, the question gets over. This is what I was saying. In the exam, if they ask a question, you will not draw the whole thing. What you will do is this. At 10 seconds, velocity is 0. At 20 seconds, velocity is 0. Initially, it is 0. So the slopes, right? At this point, at this point, at this point, these are the turning points. The xt graph slope must turn, right? Here, velocity is constant, meaning it should be a straight line. Velocity is constant, meaning it should be a straight line. Here, there is an acceleration. Now, it's okay if you don't know how it looks. Itna to idea hona chahiye, boss, it should be a curve, right? That much you will figure out it is a curve. Now, the only confusion comes, people figure out it is a curve. The confusion is this. Should I draw the curve going up or should I draw the curve going like this? That's the confusion, isn't it? Then how will you do? You look at the slope of the curve. Look at this thing. When you go from A to B, look at the slope. The slope is increasing, meaning the speed is increasing. Now, when you go from A to B, what is happening? The speed is increasing. So by chance, if the graph was given like this, A to B, this is also increasing. But if you look at the slope is decreasing. Are you getting the difference? How do I know it is an upward parabola or a downward parabola? Look at C to D, okay? When you went from C, look at this part. One thing I'm sure, there is an acceleration. So this is not a straight line. It is a curve. It's not a batata, right? The only doubt is, should I draw it like this? Should I draw it like this? So you need to ask yourself, from C to here, the speed is decreasing. So that curve, ka slope must keep on decreasing. So it should be a downward parabola. Are you clear with this? So actually exam eliminating would be easy than actually drawing the whole thing. Is this making sense? This much idea you should have about the curves, how they would approximately look like. Let's see one more like this. Now you guys give it a try. This much parabola, you should have an idea. They will teach you in max. You have a full parabola thing there. But yeah. So let's say we have a BT graph. So this is a VT graph. Let's say this is 30. This is 45. This is 60. 60. This is 30. This is 60. And this thing, right, is V is equal to T square minus 100. So that curve equation is this. Plot AT graph. Approximately, we'll see how an XT graph also looks like. So plot AT and XT graph. Like I said, you should know how to eliminate the graphs, at least for XT. AT is fine. Don't worry about the heights and all. So approximately how it would look. I'm more interested in the shape. Mano, can you keep your cam on? Done with the AT graphs. That should be easy. Give another 30 seconds. I'll show the AT graph. VT graph, XT graph, take another minute or so. See, the idea is simple. If V is not constant, it is a curve. That's it. it will look like a parabola. If I give even y is equal to x cube, it looks like a parabola. You can't really tell the difference by looking at the curve. The only question is it upward or downward? Meaning, are you going to draw like this? Are you going to draw like this? That would be the only main thing that you need to figure out. Is it a curve which is concave or convex if you talk in terms of um, the lenses? Okay, let's see the AT graph. So first thing, slope here, tan 30, 1 by root 3. Slope here, 0. Slope here, 1. Slope, 0. Slope minus root 3. Minus root 3. Minus 1 by root 3. Here we know acceleration is equal to dv by dt. That would be 2t. So the slope itself is increasing with time, and again slope is minus root 3. We are done. So basically this would be a line, then you would touch 0, then again you will go up, you will, that is 1, so it will be a little higher. So this is 1 by root 3. This would be 1, and then again you'll drop to 0, then again you'll drop to minus root 3, then again you will drop, but this time less negative. Now here the slope has become a is equal to 2t, so it's a line passing through origin. So there would be a discontinuity. It would actually bump up. Then you would see a line. Hey, wait, this was 1 by root 3. My mistake. That's a positive slope. So it would go up to 1 by root 3. And at this point, you will get a line. So I didn't draw it up to scale, but if you extend the line, it should pass through origin. That was the idea there. That would be a line. So it would be something like this. I think that would be actually discontinuity. It won't be continuous from here. It would actually take a jump because we don't know what is the time here. That value will be pretty big. So it should be a line like this. So there would be a jump. It would be a line like this. So a is equal to 2t. T is the time at that instant. So that value won't be 0 or 1 by root 3. It will be something else. It will jump, and then suddenly again the acceleration will become minus root 3. Yeah, the graph would end like this. So that's how it would look. Clear this? Where this slope would be. So in an AT graph, this itself is changing. So this tan theta will be equal to 2. All clear with this? I think XT graph would be a bigger mess. But again, let's approximately draw it and see. Any doubts on this thing? Which section you didn't understand? Please ask. Maybe for convenience, I will label them. Let's call them A, B. Yeah, it gets messed up if I put label, but ask me anywhere if you're confused. B, both 60. Okay. 60, 60. Which part? Yukti, this is fine, na, Yukti? Yukti? She got disconnected, I guess. Let's see the XT graph. Graphs are important. Maybe it's not only for this chapter. Later on, for every chapter, you will see graphs. Yukti, clear with this, right? Okay. So how will this look like? So one thing is clear. So whenever you're accelerating, so here we have an acceleration a is equal to 1 by root 3, right? So it should be a parabola. X is equal to u is 0 half a t square. So, and the speed is increasing. So it will be an upward parabola. Like I said, it will be always a curve if it is accelerating. Then velocity became constant, so a straight line. Then again, acceleration is increasing, again another upward parabola. Speed should increase. Then velocity again became constant, so it would be like this. I didn't have enough space there. Then it should be a curve again, that much I know, because there is an acceleration. The velocity is decreasing. But remember, here the slope must be 0, meaning this guy, as long as velocity is constant, your x will increase. It will go up and then it will take a turn here. So this was the turning point. And this will continue to go down. It's a parabola somewhere till here. And then your acceleration became positive. So negative accelerations will be downward, positive accelerations will be upward. So you can clearly see. So this graph, right, is negative acceleration. These upward curves, right, is positive acceleration. So now what do you have? You have a positive acceleration. So it should be upward. So the graph would look like this. It will take a turn here. And v is equal to t square by 10. So if you integrate this, dx by dt, you get x is equal to t cube by 3 minus 100t. Yeah, that is the cubic equation. It will be a curve again, and we can clearly see with time that is increasing. So that would be a function which is increasing pretty rapidly there. And then again, your acceleration velocity is decreasing, but you still go upward. You'll go like this, and this is the turning point. Yeah, it looks like this. Approximately, like, the curves and all. So till here to here, this all are parabolas. Wherever this acceleration is constant, it is a parabola. Velocity is constant, straight line. So that's how you can figure it out. If v is constant, you get a line. If you have constant acceleration, it's a parabola. If you have positive acceleration, then we are talking about this kind of a parabola. Negative acceleration would be this kind of a parabola. Again, the graph need not always start from here. It can start somewhere in the middle. So negative should be on the same level. Yeah, I didn't see that. I thought it was minus this thing. That was right. All clear with this? It's more easy to actually figure out from the options. I hope that's making sense. When the velocity is increasing and decreasing, drawing takes more effort. Anyway, that's one thing. Next one. That's all max actually. There's very little physics on that once you know what is slope and acceleration. Let's do one easy one. Let's say this is a VT graph. 10 meters per second, 10 seconds, 20 seconds. Find distance traveled from t is equal to 12 to t is equal to 18. 28 seconds. Find time when the displacement is 0. Make it 30. So find distance traveled from 12 to 30 seconds, and find the time when the displacement is 0. This is a standard mains one. Let's get it. Okay, let's see the first part. You want distance from 12 to 30. So just this is 12 somewhere here. 30 will be somewhere here. You just need to find this area. So this is one small triangle and this is another triangle. So that was straightforward. How much was this angle? This angle will be 45. How? This is 10 and this is 10. So 10 and 10, that's 45. So, and this would be 8. So this height also must be 8. So half base into height, that is 32 meters. And this would be half into, that is 20 to 30. So that is 10 into 10. That's 50. Remember, this angle is also 45. I hope everyone is clear with that angle part. So that's straightforward. So distance would be 32 plus 50. So if they ask you distance and displacement, indirectly you just have to find the areas. You will get rectangles or trapeziums or yeah, sometimes maybe a curve. What about the second part? Find the time when the displacement is 0. What do you mean by displacement is 0? Initially and finally the position is same. So and what is displacement in a VT graph? Area under the curve. So if your positive area and the negative area are equal, then your displacement becomes 0. Right, Karthik. Let's finish it off. Mostly we should be able to wrap up the graphs today. We'll be done with the chapter. Graphs, really, there's not much as long as you understand what each graph gives you, and I'll show you a few problems where you have to think a bit. Niche look, that's not the answer. Neana. So let's say at time t, let's say at time t, this thing becomes 0. So what is this area? 10 into 10, 100. What is this area? Half 10 into 10, 50. So that is a positive area. What will be this area here? So this width will be t minus 20. So this height will be also t minus 20 because that angle is 45. So what is this area? Half into base into height. So that's your negative area. So the area below the time axis must be negative. So the displacement will be that green area, which is 150 minus half into t minus 20 square. There, this is your displacement at any time t. And now you're saying this is equal to 0. That would be 300, 10 root 3 and 20. So 20 plus 10 root 3. Easy? So the area above the time axis and area below the time axis must be equal. So then they'll cancel out and you'll get 0. I hope that was fine. Easy stuff. It's all about finding areas. So that is the main thing you need to figure out. So understand that it is done. Any doubts on this? Any confusion? Please ask me. Clear, na, Ananya? Clear? Manav? Rohit? Dhruv? Shlok? Tanmay? Yukti? Perfect. Let's see one more. The next thing is acceleration time graph. So here also, if you have the graph above the x-axis, this is the positive area. The area below the axis is a negative area. So here slope technically has no meaning there. Yeah, there is a name for it. dA by dt, they call it jerk. Rate of change of acceleration, we don't use it. So really don't worry too much about it. So the primary thing that we use here is area, which is integral a dt, which gives you change in velocity. Most common mistake, people think it gives you final velocity. No, it gives you change in velocity. Area above time axis is positive. Area below time axis is negative. Yeah. Then we have one more graph. So area time graph gives you the change in velocity. Now, the variation of this, right, you will see later on. Force time graph. Now we can understand force is nothing but mass into acceleration. This is positive. This is negative. So here the area in FT graph, integral force into time, which is nothing but change in momentum. M into V. M into V final minus M into V initial. We will talk about this later on another chapter, but in case you see anywhere, it is really not that different from AT graph. You're just multiplying mass. This is also called as impulse. Clear this? That's your AT graph. So AT, FT, they're almost the same except for the mass cut. The next thing, acceleration position graph. This is one graph, which stumps people. Now see, this thing, right, can be actually on the negative side also. Time can't be negative, but X can be negative. So if you have a graph like this, So look at this. In the first quadrant, A is positive, X is positive. So this area is positive. In the third quadrant, A is negative, X is negative. This is positive. Third quadrant, both are negative. So A into dx is negative. In the second quadrant, it's a negative area because A is positive but X is negative. In the fourth quadrant, again, you get a negative area. So you can have this AX graph in all four quadrants because X can be positive or negative. Why didn't we do this before? Because time can't be negative, right? T always starts from zero. That's why we never had a graph on the left-hand side. So here you can have a graph like this. So what is slope here? dA by dx. There's no meaning here. We don't have anything for this. What about area? Area is integral a dx. This is nothing but v square minus u square by 2. Look at that formula. It looks like v square minus u square is equal to 2as, isn't it? So there. So don't get confused between AT and AX. Both give completely two different things. So same way, if I put an FX graph for this, I can just copy paste it. So you just multiply with mass, and this becomes an FX graph. You know what is force and displacement? Work done. So area in FX graph is integral f dx, which gives you work. So just multiplying with that mass, that acceleration becomes force. So they'll give you sometimes FX graph and they can ask you what is velocity and all. So don't really get confused. If you just divide by mass, you will get back your regular formulas. And the only different about this AX graph is you can have the X graph, in the negative also. And why this is happening is simple. In the first quadrant, both are positive. So here, positive A, positive X. Here it is negative A, positive A, and negative X. Now you can see that thing. So this would be negative A and positive X. Negative A and negative X. So A dx. All clear with this? And there is one more standard graph. We'll finish off with all the standard stuff. Velocity position graph. Now in a Vx graph, the slope means nothing, but we get something here. Acceleration. If you remember, A is equal to V dV by dx. So only slope doesn't mean anything, but velocity into slope. The slope at a point and velocity at a point gives you acceleration at that point. There. Example, let's say someone gives you like this. Let's say this is 60 degrees and this is 10. Then they ask you what is acceleration. So that will be A is equal to V dV by dx, which is 10 into tan 60, 10 root 3. Now, people will think this is a VT graph and they'll get the answer. Unfortunately, that will be there in the option. So always be careful. Are they asking AT graph, AX graph, VX graph, VT graph? Is it X or a T? The whole thing will change if you think X is T. And unfortunately, every time they'll keep that option of the T also. And you will solve it. You'll get the answer. That will be the first or second option. You'll become so happy you won't even think twice. After the exam, you realize and say, "Oh, I did a silly mistake." Clear with this stuff? So let's see a question on this. These are the five standard graphs. We don't have anything on AV graph. Uh, so XT, VT, AT, AX, VX. That's an AT graph. This is an AX graph. So I'm keeping the graph same. So they'll write 25 meters. Here they'll say 15 seconds. So you just need to calculate area once. Initial velocity is 10 meters per second. Find the velocity at 25 seconds. Find final velocity. Since the graph ends at 25, that's the final. Is V dvx cross product? It's just the magnitudes, Rohit. It's V into dv by dx. If you remember, right, the actual result was this. I taught you this in uniform motion. When we wrote it in vector form, no? Where did we write this? The place where it defined acceleration, I wrote it, I guess. I wrote somewhere, I'll show you later. But it's the magnitude on. Let's get this thing. The simple question. The only thing you have to be careful is it AX or AT graph. So in this case, I gave you both, so there's no problem. Let's see. I don't remember the answers. Did you guys get the area? That's the first thing. If you got the area, question is over. There's nothing there. What is the area for this? So this is a small triangle, half into 5 into 5. That's 25 by 2. This is a rectangle, 5 into 5, 25. You can split this. So this will be another rectangle. That's 5 into 5, 25. That's one small triangle there, which is height is 5. 5, that's again 25 by 2. And this one big thing is one big rectangle, triangle. That's half into base is 10 into 10. That's 50. So area will be 25, 25. That's another 25. That's 170, 125. Is the area right? Or did I go for somewhere? Check out the areas there. So for the first question, the area would give you integral ADT is V minus U. And what is the initial speed? Minus 10. So that would be V is equal to 115 meters per second. The same thing here, area would still remain same, that's 125, but this is integral A dx. This is V square minus U square by 2. So V square, and that would be 10 square, and this would be 250. So V is equal to root 350. Check your answers. Is my area right? Yeah, then there's nothing there. Once you got the area, question gets over. All clear with this? Next thing. This is a Vx graph. It's looking like this. You can take any values there. Plot Ax graph for this. I gave you a Vx, you have to show me how the Ax graph looks like. A symmetrical graph. So you can take like this x naught and 2x naught. This is V naught. Yeah. How will an Ax graph look like? Okay, let's see the starting part. So I'll just call it ABC, okay? Now, I really don't care what is A to B, but I am sure this much. A to B, it is a straight line equation. So this is looking like y is equal to mx plus c. That much you're sure. So this is looking like v is equal to m. M is the slope, x plus some constant. You can actually find the equation, doesn't matter. So dv by dx will be equal to m. So acceleration will be v dv by dx. So this is actually v is mx plus c into m. So that's m square x plus mc. If you observe, this is also a straight line with a positive slope and a positive intercept. That means if you plot an AX graph from A to B, it should be also a straight line, right? No, wait, it's a straight line, but it is not. Wait, this C is 0 initially, my mistake. V is equal to mx, so A is equal to m square x. Yeah, यहाँ पे C is 0. This is a line passing through the origin, and yeah. Now for the BC part, you can clearly see it is a negative slope. Y is equal to mx plus c. So here c is 0. You're passing through origin. And here from B to C, it is a negative slope. So the equation should look like V is equal to minus mx. Uh, what about the intercept? That intercept will be positive. Clear with this? Or you want to find the equation, you can find the equation. You guys know how to find the equation of a line? Y minus y1 is equal to slope into x2 minus x1. So you know the coordinates, you can do that. So if you do this again, dv by dx, this would be minus m. Acceleration is v dv by dx. This would be m square x minus mc. Means positive slope but negative intercept. So meaning if I put x is equal to 0, I should get the y coordinate should be minus. Meaning the graph would start somewhere here, and when I put x is equal to this, the value suddenly dropped actually. It's something like this. This is how the graph looks. So there's a discontinuity. The graph goes till here and then suddenly becomes negative and then it goes here. It will be two straight lines. You can actually, guess from the options, look at here. V is positive, here V is still positive, V is still positive, but here the slope is positive, here the slope is negative. So meaning just before B, acceleration is positive, just after B, acceleration is negative. So the value suddenly jumps from plus to minus. So in the middle, the graph, there will be a big break. It's a discontinuous graph. And finally, velocity is zero. So A is V dV by dx, acceleration becomes zero. Your graph must go from negative to zero again. Yeah, but the thing to figure out is it is a straight line. Are you clear with this? I hope everyone knows the equation of a straight line. I'll talk about it a bit. Take a break, come back by 9:45. We'll continue from here. Now we will see some physical situations and we'll try to draw graphs for that. Any doubt so far? So come back by 9:45. Yeah, let's start off. So let me just brief up the graphs a bit. No, this is a straightforward one. If a line is passing through the origin, this is y is equal to mx. So if line is going like this, then the y is equal to minus mx. It's a negative slope. right? Maybe I'll not use m. I'll just say y is equal to ax and y is equal to minus ax. If you're going like this, then this is y is equal to ax plus b. If you're going like this, then y is equal to minus ax plus b. So roughly, you should have an idea about it. So that is how the lines will look like. This is a upward parabola. Y is equal to ax square. If you just put a minus sign, the whole graph will reverse. Y is equal to minus ax square. This is a horizontal parabola. X is equal to ay square. If you put a minus sign, this will get inverted. So putting a minus sign, the whole graph will reverse. X is equal to minus ay square. Clear with this? Or I'll write this thing as y square is equal to ax. Now, in this, let me show you some variation. So y square is equal to minus ax. Now, look at this graph. So this is y is equal to ax square, right? If I give, if I change something with x, let's say if I make this y is equal to a into x minus 1 whole square. Now see what happens. When x is equal to 1, y becomes 0, meaning initially you're touching the x-axis at 0, 0. Now you'll touch at 1, 0. That means by subtracting x, you're shifting the parabola to the right. That is the meaning of it. The parabola will look same. You just shifted that origin towards right. So by changing here x minus 1, you're shifting the parabola left and right. Suppose if someone gives you y is equal to a into x plus 3 whole square, that means you're shifting when x is equal to minus 3, your y will be 0. So you're shifting the parabola to the left hand side. So by putting plus and minus with the x, you're shifting the parabola right and left. Right. So if I draw one more like this, so same thing, if I put a minus sign, for this thing, if I put a y is equal to minus a into x plus 3 whole square, then it's like you're shifting the whole parabola down. And if you do something more, let's say you add something to y also. Let's say it is y minus 1 is equal to a into x minus 3 whole square. Now look at this. When x is equal to 3 and y is equal to, when x is equal to 3, y will be 1. Or x is equal to minus 3, your y ka value is some 1. Meaning when you shift y ka value, you pushed it here, minus 3 comma 1. So your parabola will be with a minus sign. If you take plus sign, then it will be upward. So whenever you change y ka coordinate, when you add something to y, you're pushing the thing up and down. So changing y will push the parabola up and down. Adding something to x will push the parabola left and right. So if you have something like y minus 1 is equal to minus a x plus 3 whole square. So that minus 3 and 1 will tell you that, what should we call that? So it'll tell you about this point here, the turning point. So minus 3 comma 1, it's a minus graph, so it will be negative. Roughly getting an idea what is happening there. So just have a rough idea about it. It's not necessary exactly should know how it works, but that is a thing. So y is equal to x square. You add something to x. If you add something, it will go to the left. If you subtract something, it will go to the front. You're shifting the parabola left and right. If you mess something with y, then you're pushing the parabola up and down. So the general equation is this: y minus h is equal to a into x minus k whole square. So this is a parabola whose the bottommost point is k comma h. The same thing you can play with the other one also. If you have something like x minus 2 is equal to a into y minus 2 whole square is equal to a into x plus 1. Now, this is a horizontal parabola. See what happens there. When x is equal to minus 1, y is equal to plus 2. And this is a horizontal parabola. So someone took the horizontal parabola and they shifted it left and up. This was the basic graph, isn't it? Y square is equal to ax. Y square is equal to x looks like this. So when you added plus 1, you shifted it by 1 backward. When you subtracted 2, you shifted it upward by 2 units. So the parabola came back by 1 and went up by 2. You're getting what is the meaning of those graphs? That's one way to think about, when you draw the graph. So, but like I said, it will be more easy for you to eliminate options, but sometimes if you are unable to eliminate it, so remember this. More about this, Max people will teach you in Parabola. You have a full chapter on that. So let's go ahead with this. Now, the next one, this is an important question. These are the kind of questions you can expect in advance. A particle is projected with speed u. We have done this already. It goes up, hits the floor, bounces back with u by 2, goes up, comes back, bounces with u by 4, and so on. We did this problem before, an infinite GP. I think I asked you to find the total distance and total time. Up is positive, down is negative. That's the convention we will stick to. Particle is projected with speed u. Its speed becomes half after colliding with the floor. Plot velocity time graph. This is what I'm saying. This is another type of asking. They'll give you a physical situation. They'll expect a graph from you. Velocity, position. Position here is y coordinate. Displacement time graph. Distance time graph. Yeah. If I had to ask you in the exam, maybe I'll ask you Vx and distance time graph. Even VT graph is a good one. Let's get them. At your level, this would be a pretty good advanced question. Yeah, after 12, when you're in 12, this will be again still an advanced question, but easy one. For now, it's a good one. Let's try this. And you have seen this question before. In Kinematics 1D, we did the exact same thing. I didn't ask you the graph, though. If you remember, this was a question. Nothing changed. Data was same. Everyone should try. Velocity time graph. I'll give you a minute for that. Just to give an idea. Imagine I give you some options like this. ऐसा अगर 6 ऑप्शंस दिया किसी ने, again, you can't find the right one, but can tell me which are wrong. You should have a logic now why this is wrong. If I draw like this, meaning it is going till infinity. If I draw it till here only, meaning it is ending there. What do you guys think? D का graph is going till infinity. E का graph is ending somewhere here. I'm telling you how to guess basically. So you can clearly see at t0, your speed is not 0, right? So this graph is wrong. Why? T0, V is 0. So anyone who passes from the origin is gone. This is also gone. See, you took the initial condition at t0, V must be 0. So the graph should start, should not be 0. So the graph should not start from origin. Second thing, we know V is equal to U minus GT when it is going up. So it is pretty clear it should be a straight line. So F is anyway gone. And next thing, if you observe, no matter whatever is the speed, the acceleration is always constant. And you can clearly see the acceleration tan theta is minus g. This is constant. So the slope should be negative. This is gone, positive slope, right? And b is also gone. Why? V is always positive. When you are coming back, velocity is negative, isn't it? When the particle is coming back, velocity must be negative. This graph does not go into negative region. So you're actually left with d and d. And they look same, everything same. The only difference is this guy is going till infinity, this guy is ending here. Got it? So there, that's how you eliminate options. Like the D and D option will be there. That's where you'll get stuck. So you have to do some work there. If you have actually done something, you will realize the answer directly. So how to draw this graph? So let's see this. I'll just take it from here. If you remember something here, we got a constant time. The graph will wind up at 2t. You cannot go till infinity. So E is the answer. D is wrong. The graph will not go till infinity. We can clearly see here the total time of flight will be t plus t by 2 plus t by 2 square and so on till infinity. This comes out to be 2t. And second thing, we can clearly see the graph. So initially V is equal to U minus GT. For this after collision, the graph V is equal to U by 2 minus GT. So that means all these are straight lines with a negative slope and the graph should end at 2t. So when you draw a VT graph, so you will have parallel lines. And look at the time interval. The time interval is becoming smaller and smaller. So here you'll start with U. Here you'll start with U by 2. This should get even closer. U by 4. There. So this would be T. This would be T by 2. This would be T by 4. This would be T by 8 and so on. The graph cannot cross 2T. You cannot go till infinity. There are infinite collisions, but the total time is finite. And if you look at this slope here, all these are parallel lines where tan theta is equal to minus g. Is that clear, everyone, with the graph? So every time you collide, so look at this thing, look at this graph here. Initially, your speed is u upward. As you go up, speed will decrease, decrease, decrease. This point is your h max. So this point is your time of ascent. After that point, your velocity becomes negative, negative, negative. Here the collision happens. So this breaking, right? The graph breaks actually in the middle. So this is your first collision. So every time it collides, suddenly the velocity will change. So there will be a break in the graph. This is a discontinuous graph. I hope everyone understood how to draw this. Can you draw the remaining three? So the graphs will not go to infinity. The time is finite. The distance traveled is finite. So there is a limit. Let's see the Vx graph. The first question is always this: how will the graph look like? Is it a straight line or a curve? If you can answer that, that will make your life a little easy. If you see the equation v square is equal to u square minus 2gy. Y is the height. So this is a parabola. If you rearrange the equation, you will clearly see this thing. This will look like v square is equal to, take out minus 2g common. This will be like y minus u square by 2g. If you clearly see this, this is looking like x square. You want to put that in y, now. I'll just call it, keep it as s or y. So this thing gives you the feeling of y square is equal to minus a x minus some constant. It looks like this. And we clearly know it is a horizontal parabola. A negative sign indicates inverted parabola, and it got shifted minus b. So this is the parabola. So the minus y square is equal to x is a horizontal parabola. Minus n meaning leftward parabola. X is equal to minus b meaning you shifted the parabola by b to the right. So this point was b comma 0. So that is how the graph should look like. You will see an interesting graph here. See carefully. So when y is 0, so this is vy graph, your velocity is plus u. So the graph starts here. It should be a parabola like this. This point here is your h max, because that's when the velocity becomes 0. So this is plus u, this is minus u. So the below the graph meaning velocity has become negative. So this is how you see everyone. This is the starting point. You're going up, you're going up, you're going up. Look at this, y is increasing. This is a graph. This is not a path. Right? As you go up, speed is decreasing. So go up meaning y is increasing. Speed is decreasing, decreasing, decreasing. You became 0 at h max. At h max, you took a turn. So velocity becomes negative. So the graph will be negative values here. Look at the value here, minus v, minus v, minus v. The velocity is becoming negative, 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 more negative. You hit the floor at minus u. Once you hit the floor, the speed will become u by 2 positive. So the graph will start from here. Again, you will get a parabola. This time the graph will end at minus u by 2. And this point will be h by 4. Every time the speed becomes half, h max becomes 1/4. Then the graph will start from u by 4 like this, then like this, and then we'll get an onion type graph. The graph is going like this. It starts like this. This is HV versus Y graph. Is that making sense, everyone? So it's a horizontal parabola. So every time you hit the floor, the graph will jump. So it's like you're going down, then it will jump. Going down, you will jump. Going down, you will jump. Going down, you will jump. So we will not show that jumping partly. That's a negligible time, so we will just show a discontinuous graph. That's what I said. This thing makes the question good. Like the headache was the math part actually. How does that equation look like? What about displacement time and distance time? If they ask you distance traveled, you have to find the displacement first. Again, going back to the equation, y is equal to ut minus half gt square. This is actually your, if you see, this thing is looking like y is equal to ax minus bx square, your equation of trajectory. So this would be a little easy to draw. So initially your y coordinate is 0, you will increase to h max, then you again come back. It kind of looks like projectile motion, but it is not. This is your time of ascent. This is your time of flight. This was your h max. Then your speed becomes half, so you will go lesser height. So this will be t, this will be 3t by 2, and this time the height will be h by 4. This is h. Then again it will be smaller, 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 smaller. Remember, you cannot cross 2t point. So you'll get small, small, small parabolas. This is your displacement time graph. What is the difference between distance and displacement then? The distance is always an increasing function, right? So distance can never decrease. So that's the first thing you need to understand. So whether you go up or you come down, it should be always increasing. Distance is an increasing function. So in a graph, you can never have negative slope. Slope is always positive. So how do we draw this? So in a displacement time graph, you flip the parts. Wherever you see the graph is going down, you flip it. So this is how it looks. Look at the starting part. Is it increasing, increasing, increasing? Fine. If you're increasing, I don't have a problem. I'll draw the same thing. Now, the second part, what happened there? You're decreasing, the graph will flip. This is what will happen. So whatever is supposed to happen down will happen in the upward direction. You flip the graph. Then again, the function is increasing, so no problem. So whichever is increasing, put it there. Again, the graph will flip. It should be supposed to be down, flip it up. So this part which is coming down, this will flip up, right? And then again, it will keep going up. Then again, we will draw it up. Then we'll flip it up, and then so on. So you have to keep flipping the parts. So flip the parts which are decreasing. So anything that is trying to curve down, push it up. Is this clear, everyone? Distance time graph. So first you have to draw the displacement time graph, and then you have to put it there. Clear? Now I'll give you one more like this. You try this. You just try to draw this. So let's say this is displacement time graph. Hmm. Can you draw distance time graph for this? Done. Like I said, whichever is going down, you have to flip it up. So the function should never come down. So look at the starting part. Increasing, no problem, increasing. The second part is going down, flip it like a mirror image. So just it'll go up. So instead of going down, it would have just gone up. Then again, this part is increasing, no problem, increasing. The second part is trying to go down, flip it. This line is also trying to go down, flip it. You just keep flipping it like anything that goes down. Then it became constant, no problem. Constant is okay. Then it is increasing, fine, just put it up. Got what we did? Anything that was trying to decrease, you flip it. If you're constant or increasing, you're okay. You just have to keep adding to the previous part. The distance will always increase. The function can never decrease. Clear with that? So distance time graphs are good ones. Like you should know your displacement time graph and then get it. Great. Next thing, let's see a few more. Let's get this theoretical question. I'll send you a sheet in that also there. These questions are there in that sheet. Let's see the question. Now here, the most common mistake is this. A is increasing and decreasing, therefore speed is decreasing. That's a blunder. Most people do that without understanding. You need to understand something here. Speed velocity will decrease when A is negative, right? As long as acceleration is positive, right? Velocity will keep increasing. So here what is happening? Acceleration is increasing and decreasing, but it is always positive. So understand the meaning of acceleration. It is a rate of change of speed, meaning the speed at which you're increasing is decreasing. I'll give you some numbers, but always positive. That is, speed increases. Speed decreases if A is negative. Then velocity decreases. Think of like this. Just some random numbers, okay? Let's say this is acceleration, 1 meter per second square, 2, 3, 4, 5, 4, 3, 2, 1. So A is increasing and decreasing. Time, let's say 1 second, 2 second, 3, 4, 5, 6, 7, 8, 9. Look at the velocity. Let's say initially your speed is 1 meter per second. Now understand the meaning of this. For 1 second, you have acceleration 1, right? So acceleration is 2, meaning next second your speed will increase by 2, so you'll become 3. Next second your acceleration is 3, so you'll add plus 3, so you keep adding that, getting it? So whatever was the acceleration, you keep adding the speed. So this is the meaning of it. If your initial velocity was 0, you'll get 1. So the 2 meaning, so you get 1 plus 2, so that becomes 3. Next thing is 3 plus 3, you become 6. That is the meaning of it. Acceleration will increase your speed by 4 meters per second. So whatever you have, 6, plus 4, you'll become 10. Then it will be 10 plus 5, that will be 15. Now look at this. A is decreasing. 15 plus 4 is 19. You're still increasing. 19 plus 3 is 22. You're still increasing. Are you getting this? Acceleration is decreasing, but your speed is still increasing. So displacement and velocity both will increase. Is that making sense? I'll give you one more crude example. So think of like this. I gave you 100 rupees. Money increased. I gave you 200 rupees. Money increased. I gave you 300. Money increased. I gave you 400. Money increased. Now I gave you 300. Did the money still increase? I gave you 200. Money still increased. I gave you 100. Money still increased. I gave you 1 rupee. Money still increased. I took away 100 rupees from you. Now it will start decreasing. So understand that. So as long as A is positive, you will keep increasing. So that's the thing. Not difficult, but people see that graph and think like, oh, A is decreasing, so it should decrease. So happens. You just have to be careful. Let's get this. So you can even have graphs in projectile. Any answers? Let's get the data from the question. What is talking? A projectile is projected from a level ground, making an angle theta with the horizontal. See, always put a small graph. You don't know how to start the question, put a picture. It's not like the picture will help you. Once you put a picture, right, you're telling your brain, okay, let me see what do I have. You'll actually become a little calm. And like I said, if you can't draw a picture, means you didn't understand the question. Just put some random picture, even it looks useless. Uh, the vertical component y of the velocity. So he is talking about Vy. So the graph is not clear, but this is actually Vy. And he said this is 10 and this is 45. So great. So this thing is actually also 10 meters per second. We can see that from the graph. So indirectly, you gave u sine theta, which is your Vy, is 10 meters per second. Perfect. And look at this point here. At this point, your Vy is 0, where at x is equal to 10. Where is Vy 0? At the h max. So this is your, he indirectly gave you the range. So he's saying this was 10. That means this is also 10. Perfect. So time of flight is 2 Vy by g, which is 20 by g, 2 seconds. Right? And then range is nothing but Vx, which is u cos theta into time of flight, which is 20 meters, and time of flight is this. So u cos theta is also 10. If u cos theta 10, u sin theta 10, tan theta 1, theta is 45 degrees. Done? That's it. So this thing is not like any standard graph. You need to pull data from the graph. So understand, every time you won't get that 5 standard graphs. Sometimes the graphs are non-standard graphs. You can't use any regular stuff. So the graph is simply giving you data. All clear with this? Let me show you one more like this, where the graph doesn't make any sense, but you need to pull data from there and solve. For example, they give you something like this. It's a graph between v square and 1 by x cube. Some weird graph. The graph is looking like this. This angle is 45 degrees, and this is 1 by 8, and this is 1. This point is B, and this point is A. Now, v square 1 by x cube, what graph is this? There's no graph like this. Find acceleration and time taken to go from A to B. Let's get this. Now, these are non-standard graphs. So the idea is to get the information, maybe mathematically get the equation or the data, and then use your kinematics to solve. So when you see the first thing in the graph, the first thing you should feel like, forget about v square and x cube. This is a straight line. So for a straight line, and that to this line is passing through origin. So y is equal to mx. That's what you should think of. Y ka place mein you have v square, x ka place mein you have 1 by x cube. M ka place mein we have tan 45. There, indirectly, they gave you an equation relation between v square and x cube. Understood what I'm saying? So you need to use that. It is a straight line and get the data from there. And then it's your regular calculus. So this is how you would start. You will say this is a line passing through origin. So y is equal to mx. Y का place में we have v square. M का place में we have slope tan 45. X का place में we have 1 by x cube. So indirectly, it is given in the question v square is 1 by x cube, or v is equal to 1 by x power 3 by 2. Now, once you know this, right, Karthik? So you know how to find the acceleration. We use your calculus. What is acceleration? A is equal to v dv by dx. So v is 1 by x power 3 by 2. And dv by dx will be minus 3 by 2 x power 5 by 2. So acceleration will be minus 3 by 2 x power 4. That's your acceleration. Now they're asking for time. If you give me x ka value, I can find the acceleration. They can ask you find the acceleration at A. So put x is equal to 1 and you'll get acceleration at A. We also know v is equal to 1 by x power 3 by 2. So I can write this thing as dx by dt. So dt is equal to x power 3 by 2 dx. 0 to time, you're going from A to B. So A is 1 and B is 1 by 8. So, no, wait, that's not. Want from A to B now. So this is XA, which is 1. XB is 2. Because this is 1 by x cube. So 1 by x cube is 1 by 8. So x cube is 2. Then you can integrate this. So this would be x power 5 by 2 by 5 by 2. Limits are 1 to 2. This is 2 by 5. 2 to the power of 5 by 2 minus 1. That's your time. So when they give you non-standard graphs, mostly it is calculus ka question, right? Or something like this projectile ka question where they're giving you data. The area, the slopes don't make any sense. So if you ask me, most of the time, it is somehow you have to find the relation between the two variables. It could be v square, x cube, or anything. Once you got that, you can clearly see the whole thing looks like calculus question. Clear? Let's see one more like this. But I hope you got it now. Once I got this equation, v is equal to 1 by x 3 by 2, question got over at that point. The graph was just looking weird and scary, like, oh, v square and 1 by x cube, what the hell? It's about getting the data there, nothing much. So let's say one more. Let's say it's a graph between x and 1 by v. This is 2. This is 8. This is 3. This is 15. This is not passing through origin. You can clearly see. Find time taken to go from x is equal to 3 meters to x is equal to 15 meters. Then another non-standard graph. Rohit, you're there? Okay. This thing, if you actually see, right, there is something there, but I mean, there is a relation between that. But click nahi hota exam mein sometimes, it's like if you give me this thing, it doesn't click me like, oh, what the thing and all. There could be easy way to do this. I too will go always brute force. I will say this is what I do. So to keep it simple, like, there's not necessary every time to actually figure out. Maybe the examiner intention is, that there's an easy way to do it. Yeah, the examiner generally knows it, but it's not necessary every time you can figure it out. So one thing is clear, this is a straight line. So this is looking like y is equal to mx plus c. Y का place में we have x, m, x का place में we have 1 by v plus c. So if you can get m and z, my job is done. So this is looking like, and slope though I know from here, this is theta. So this height will be 12 and this will be 6. So tan theta is equal to 2. So this is slope is 2. C ka value I can find. So when x is equal to 3, 1 by v is equal to 2. Substitute there. So 3, this is 2 by 2 plus c. So c is equal to 1. C is no, wait, it's not 1 by 2. 1 by v is 2. So that is 2 into 2 plus c. So c is equal to -1. Great. So we know the equation. X is equal to 2 by v plus 1. That's -1. Perfect. That's your equation. So we get 2 by v is x plus 1. And then I can write v is equal to 2 by x plus 1, which is nothing but dx by dt. So this is 2 dt is equal to x plus 1 dx integral to dt 0 to t, and this would be x dx plus integral dx. X ka value goes from 3 to 15 and 3 to 15, and this is 2t, that is 15 square minus 3 square by 2 plus 15 minus 3, that's 225 minus 225 minus 9 by 2, that's 216 by 2, that's 108 plus 12, 120, t is equal to 60 seconds. 1 minute. Got this? That's brute force. Matlab, I know it is an equation, get an equation, solve. Works. But this specific question, there is a way to do it in a faster way. Now, if that clicks in the exam, great. Maybe it will click for others, but if it is me, it doesn't click for me. So the idea here is this. We know v is equal to dx by dt. So if you put dt this side, and if you bring v this side, 1 by v dx, and if you put an integral on both the sides, integral dt is integral 1 by v into dx. So the time is nothing but 1 by v dx. So this is the area under the graph, but which graph? So be careful here. This should be the height, and this should be the width. If you remember an integration, how we took the rectangles. So the rectangles must be taken like this. So 1 by v must be the height. So they're talking about this one. And dx must be the width. You're getting which rectangle they're talking about? So the area must be taken that way, horizontally. So we are talking about this area, where this width is 12, 15 minus 3. This is 2. And this was 8. So if I can find area of this rectangle, then my time will come. So area will be half into base is 12, and the sum of the heights is 2 plus 8, which is 10, which is 60 seconds. Faster? But you should realize, boss, I should take the horizontal area, not vertical. Normally, if you remember strips, we take vertical. Here, you're taking the horizontal projection. So yeah, if it clicks, then you'll get this in less than a minute. Doesn't click, yeah, it'll take 2 minutes. Big deal, can be done. What if this is 1 by v squared? Then you're dead. Then there's no shortcut anyway. Then so you have to do brute force. But clear with this. So this is how you handle non-standard graphs. So that's a bit about graphs, and with that, we are done with the chapter. So we have done a lot. I think almost 84 questions, right? So that itself is a good chunk of questions there. I'll send you one sheet on graphs also. So when we catch up on Wednesday, we'll start off with a new chapter, units and dimensions and errors. Units and dimensions are fine. They're really not that great, but errors is really important, right? Comes a lot errors, and there is something called significant figures and all that stuff. We need to do that before other chapters because they do pop up. Even when you're doing a chapter like work per energy, they'll ask you find the error in energy, find error in work. The questions will keep coming. So not a big chapter. I think that should take 2.5 classes, maybe 3 classes max. We will do at one level there, but I'm going to do the chapter again when the portion gets over in the revision. Also, we're going to put some special slots for it. And after that, we'll go ahead with NLM, friction, and all that stuff. So, okay, with that, we'll wrap up for the day. And some of you have noticed are not giving the test. So I don't know why. I'm giving you 6 days of time.